Record. Okay. Hey, thank you. Okay, so let's start. We're starting at the top of page 2 of our review guide. No luck. Can't find it. Raggy. Notebook paper. Okay, so we were working on conversion units. We were using our unit multipliers to convert units of, I think in the case we had, it was rates of speed. This continues that. So number 14 is state the unit rate if it costs $27.50 for 11 gallons of gas, if only. So let's see. Number 14, we have $27.50 for 11 gallons of gas. So how are we going to express the unit rate if we're talking about a payment for an amount of gas? Dollar per gallon. Very good. So we've got dollar, and what does per mean? Right. And we see it in our unit rates for everything, right? It's dollar per ounce if we're buying something in the grocery store, dollar per gallon if we're buying gas, like you see it on the sign. So remember that per equals division. And so we need to find the unit rate for this, which means that we need our denominator to be what?
Our denominator is gallons.
Our denominator is gallons. What is the value? What is the number of gallons when we create a unit rate? Nope. 1. Unit rates is like a unit multiplier. Unit rates, and I know y'all knew this, but you're like, we're trying to figure out how much money for 1 gallon. And so all we have to do is we have to, I mean, you understand the math of it. I'm just trying to explain to you the concept of the principle so that you see it every time you get a problem like this. All they're asking us to solve is how much it is for 1 gallon when they ask for the unit rate. So you must have your denominator equal 1. So we have $27.50 for 11 gallons. And so all we do is we divide 11 into 27.5. So I think everybody's got a good concept of the math. I just, felt like confusing you a little. Sorry. 27.5 divided by 11 means it is $2.50 per gallon of gas. It's been a few years since we saw that. Okay. I did a little. If I can get you to understand the concepts, you use these constantly. You really do. Okay, so number 15 is giving us a word problem. Addison drove 960 miles in 16 hours. What was her speed in miles per hour? Now, again, these are very simplified problems. We are assuming that she slapped on that cruise control and that her cruise control went the exact same speed for the exact same, or for the entire distance. Yeah, right. Super cap, because there's no car that I know of that can go 960 miles on 1 tank of gas. So she had to stop at some point. But in the case of these word problems, for the sake of universal motion, we just pretend that she kept the same speed the whole time. So so they're already telling us our unit rate. What's our unit rate? Everything else, right? Everything else. Speed is miles per hour. So how many miles did she travel? 960. How many hours did she travel? So what do we do? Yep, you have to turn hours into 1. So this is 960 over 16 times 1. So we can just divide the numerator by 16. And that leaves our denominator as 1. 960 divided by 16 is a nice even 60 miles per hour. Okay, so for number 16, what is the unit rate if a truck uses 85 gallons of diesel for a 1,530 mile trip? Miles per gallon? That makes sense. So you can also see this as proportions. So we're trying to find the proportion. So I'll do this one in terms of proportions because that's kind of what they're asking us to do. So if we have miles per gallon on one side and we want to find out what that equals miles per gallon. So what did they give us? How many miles did the trucker travel? $1,530. Okay, thank you. And how many gallons of diesel did he use? Right. And what do we know about the miles per gallon on the right side of our equal sign? Where? Yeah, the gallon must be 1. And so the miles is our unknown. And this gives us the exact same problem. But this kind of helps you determine what gets divided by what, so you don't do it in the wrong order. Because now that we have it set up as a proportion, what do? We can cross multiply. All right, so we're going to put the x on the 85x on the left, and 1,530 miles times 1 is just 1,530. And then you divide both sides by 85. Now, if you'll notice, that has still set up the problem just like we have it on the left side, 1,530 miles divided by 85 gallons. So in the previous problems, I just let you look at that and know to get rid of that 85 in the denominator, you just do your division, divide the numerator by the denominator and that leaves the denominator as 1. Just turns it into a whole number. But this shows you the math of why that always works. So once we cross multiply, we can isolate our variable and we end up with the unit rate. Let's see, clear 1,530 divided by 85 is 18. So that's 18 what? Miles per gallon. What do you think? Is that good? For diesel? For I would assume this. I'm assuming this would be like a semi, like a transfer truck. What do y'all call those? 18-wheeler transfer truck, semis? I call it a transfer truck and people have no idea what I'm talking about. Tractor trailers. Call them tractor trailers here. Yeah. Okay. So he got 18 miles to the gallon on diesel, pulling a tractor trailer. So.
Oh, are they calling tractor trailers because they trail tractors?
So it might have something to do with the cargo section is called a trailer.
Yeah.
And yeah. We're gonna keep going. I love that I have that in a video now. Okay. Let's see. I gotta hold on. How long do I keep you guys? This is third period. Okay, so good. We've still got 11:55. That's right. We lose a little bit, like 5 minutes at lunch. That's okay. Be all right. Okay, so let's go ahead and move on to section 3. So section 3 is talking about similar figures. So we're working with similar figures. We're calculating area and possibly volume, perimeter. So again, proportion is very, very important here. So if you look at number 17, we're using the figures on the right for 17, 18, and 19. So we have 2 rectangular shaped cubes. So let's see. So first, 17 asks us to find the value of X. Why do that? Of X. Let's see, I might can draw these. Not really my thing. Mine's gonna be a little wider and obviously a little loopier. Straighten that line up a little bit. There we go. So there's one. And then why did that? Got a bigger one. Oh, so yeah, y'all are at the squeaky table. Usually I put that table up so it doesn't squeak. It doesn't take much. That table's awful. Sorry. Okay, so in this case, they want us, what have they given us? They've given us this bottom front width of 4. They've given us a height of 12. The other one has the bottom width is X and the height is 15. So what do we know that's proportional here? If we're told, so we're assuming that we've been told that these are similar figures. So that means what about these side lengths? They're proportional. Their proportion is the same. So how could I set that up? Okay. Equals X over 15. Right. All right. What if I had written it 4 is to X, what 12 is to 15? Would that also work? Yes. Because look at the equations. When we cross multiply these, I end up with 12x equals 4 times 15. When I do that here, I still end up with 12x equals 4 times 15. The most important thing and the problem that I saw with the quiz we did on this section is that you would say 4 is to 12, what 15 is to x. Do you see why that's not the same proportion? If you have the base width in the numerator on one side, you need the base width in the numerator on the other side of your equal sign. If you have the height in the denominator on one side, you need of the smaller figure, you need the height of the larger figure on the denominator on the other side, right? That is the most important thing. Whatever is in the numerator on one side needs to be the same part of the figure on the other side from the other figure. Or I would see, 4 is to X, what 15 is to 12. That would be the same thing. In this case, I've got the smaller figure base against the larger figure base, but then I've got the larger figure height against the smaller figure's height. So it's still, the proportion is not right because it's not the same on both sides. So that's where you've got to be super careful. So this is the equation we need to end up with, that 12x equals 4 times 15. So what do we do first? Yeah, we got to simplify. So we do the multiplication. 12x equals what? Remember, 15 is like the quarters of a clock. 60 minutes is an hour. There's 4 15s in an hour, so it's 60. And when you divide both sides by 12, you find that x equals what? Yeah, 12 goes into 65 times. So x equals 5. All right, I'm just going to move over here so I can keep my same figures. All right, so number 18. See how I'm doing. Doing good. 18 says if the top of the larger figure has an area of 100, bless you, what is the area of the top of the smaller figure? So we're looking for the area of the base. Now with these being cylinders, sort of, they're like prisms. The bases are the same size. So you would call this just the top base and the bottom base, still a base. Okay, so the larger one is 100, right? So this is 100, and then units, what? Just units? Area is always squared. So remember, it's 100 units squared. And then we want to know what this one is. Now the units, the reason I add the units here, we don't know what they are, so I'm just going to do u squared. Is because you need to remember part of your proportion must be squared because we're calculating area now. So what is the area of the top of the smaller figure? So somebody give me two parts, or give me a part of our smaller figure and our larger figure that are proportional. Anybody?
4 and 5.
You want to do 4 and 5? Okay, so we'll do 4 over 5. Okay, and so we can use sides to calculate the proportion of the area, but we have to make some adjustments. Hold on. Okay. All right, sorry. All right, so that would be proportional to which area over which area? Which one would you have in the numerator?
12 over 15.
Well, we know the sides. We're asked to calculate area. So it's x over 100 u squared. But what do we have to do to our sides to make them match the proportion of the area? You remember? That's why we're going to have this example. So make sure you write what we get. You must, because the area is what? Area is length times width. So it's x times x, so it's x squared as or unit times unit, so it's unit squared. And so you have to square your sides. And when you do volume, you have to cube them. It's length times width times height, so it's unit times unit times unit, unit cubed. So you must cube the sides, but the proportion of the sides is exponentially squared if it's going to equal and help you calculate the area as a proportion. Sorry, I think I said that a little bit weird, but this is the math. Okay, so we need to simplify before we cross multiply. So what is 4 over 5 squared?
16 over 25.
Right, we just square the numerator and square the denominator. So 4 times 4 is 16, 5 times 5 is 25. That equals x over 100. So now we can cross multiply and we end up with 25x equals 1,600. Which is good because 25 is going to divide evenly into that. All right, so 25 goes in 166 times with 5 left over. No, yes, no, 10 left over because that's 150. And so then 25 goes into 100 4 times. So that's 64 units squared. That is the volume of our base of the smaller figure. Now, does that make sense? Should the area of the area of the base of the smaller figure be a smaller value than the area of the large figure? Okay, so if you got that, you were good. Now, these two, you know, there's only a difference of, 3 times between 4 and 12 and 5 and 15. So if you have like a super, super small area, like if that was like 20 to 100, that's a much bigger proportion. That's a much bigger ratio than 4 to 12 or 5 to 15. So you might want to check your math if you have if it's super tiny area, but that everything else doesn't have a huge difference, or if it's bigger than, and you're calculating a smaller figure. So you should be able to use a little bit of common sense to sort of look at your answer and find out, does this really make sense? Okay, let's look at number 19. Is number 19 calculating volume? Yes. Okay, so if the volume of the smaller figure is 192, what's the volume of the larger figure? So volume of the smaller is 192. I would go ahead and just, as a reminder, to always cube when you compare sides to volume, put that unit cubed there, and then we are asked to calculate the volume of our larger figure. Now, again, because these are exponentially different volume and area and sides, you're going to see a larger number gap in volume, but it still should be, the ratio is the same. Okay, so let's go ahead and still use 4 and 5. Why not? Those are the smaller numbers. Keep it simple. 4 over 5 cubed equals what over what? Yep. So 192 over x. Now what's 4 cubed? 64? Yep, 16 times 4 is 64. And 5 cubed? Yep, 125. 5 times 5 is 25, times 5 is 125. Okay, equals 192 over x. So we cross multiply. I don't know why I'm just so random with these colors. All right, so when we cross multiply, I'm head over this way. We have 64x equals 125 times 192. That equals 24,000. I'll do that math for you. And last step, we isolate our variable using the multiplication property of equality. And x equals 375 units cubed. Okay, let's do one more. Let's look at this scale problem at the bottom, and then I'll let you guys go. Shouldn't take 5 minutes. All right, so in this case, the distance between Sun Valley and Johnstown is Johnstown. Okay, it's 55 miles. And on a map, the distance is 10 inches. So determine the scale of a map, of the map. So what do we know about the scale of a map? It is a ratio, right? And in this case, yes, we're working with inches and mile. But it's always, like, what is always your 1? Right, the smaller map scale. So a scale is always going to be X miles to 1, in this case, inch or centimeter, whatever they've got it set up as. So there's an understood 1 there when you're looking at scale that you need to make sure that you don't miss. So that's what we're wanting, X number of miles to 1 inch. And that is comparable to what do we know that we can write with the same ratio? 55 miles over 10 inches. Exactly. So that allows us to cross multiply, and we end up with 10x equals 55. Last step, we divide both sides by 10, and x equals 5.5. So what does that mean? Yep. So your answer for this, what is the scale, is you can write it different ways. 5.5 miles. This is how you'll usually see it on a map, to 1 inch. You have 5.5 miles to 1 inch, or you can just say 5.5 miles per inch. We don't really usually write it as a unit rate. That's kind of what you're wanting, but all of them tell me the same thing. Okay. All right. Thanks, guys.